All right, these are Unit 3B quiz/test review notes. Again, you're going to keep these. You're going to be able to use them on your test and keep them for your notebook. So you're going to have a question like this on this test that asks you to write a sentence explaining the graph. So you're going to look at what does each ordered pair mean, what's the rate happening, what does our x-axis representing, what is our y-axis representing. So if I look here, this is our money and savings. So 0, 10 would mean that we start with $10 in savings. So begin with $10 in savings. Okay, and then it decreases or decays exponentially reaching $2 at 6 weeks. Okay, or something similar to that, where you're talking about we've addressed both ordered pairs. It's not going down in a linear manner, it's going down in an exponential because it's going in that downward curve. So make sure that you're talking about each ordered pair. Okay, you're going to have 2 questions where you've got stories, tables, graphs. Okay. So the city of South Jordan is growing at a rate of 5% a year. If the population is 40,000 now, in how many years will the population be 50,000? Okay, so at year 0, our population was 40,000. In order to get a growth, we are going to 5% a year. We're going to multiply by the 100% plus the 5% growth. So we're going to multiply by 1.05 every time. So year 1, 2, 3, 4, 5. Maybe we'll need 6 or 7. We'll see. So multiply 40,000 by 1.05, and that gives us 42,000. Take 42,000 times by 1.05, and we get 44,100. Take that times by 1.05, we get 46,305. And I'm rounding to the nearest whole person because we don't, when we're talking population, we don't count half a person. And the next one we have 48,620. And last in our box, we have 51,051. Okay. So it reaches our population year 5 that we're looking for. Now, because this doesn't have any labels on our graph, we're going to want to make sure that we label it. So the x-axis was our year. Our y-axis is going to be population. And I'm going to say in thousands. Okay, that'll just help me a little bit. Okay, and then we've got to get to 6 years so we can skip count. So let's skip count here. So 1, 2, 3, 4, 5, 6. Okay, and then we're going to skip a lot. We can skip up to like 40,000. So okay, so we can do 40,000, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, etc. Okay, so that's going to give us a little bit. So that's what that little break means. Means we skipped a whole bunch of numbers. Okay, so at 0, we had 40,000. Year 1, we had 42,000. Year 2, we had 44,100. Year 3, we had 46. So where's 46,300? Year 4, we had 48,620. So about there. And year 5, we had 51,051. Okay, so because these numbers are not growing all that much and it's kind of slow, there's a slight curve to our line, but it's not going to be super obvious depending on, because of our scale, that it's. Is this graph continuous or discrete? So continuous means happening all the time. Discrete meaning you can count it. So I'm going to say this is discrete because we can count people. However, I mean, you're always talking about kids being born, so you could probably argue it being continuous as well. All right, so we have some end behavior and domain and range. We've got 3 questions like this on your test, and they're 7 points each, so you need to make sure that you know what's happening here. So here we have a straight line. When we have a straight line, as long as it's not vertical or horizontal, our domain and range are negative infinity to positive infinity on both of those. Okay, because we're representing everything that can be an x value and everything that can be a y value. End behavior, we start as x approaches negative infinity, so our left-hand side. What's y doing? Well, y is going down, so y is approaching negative infinity. As x approaches positive infinity, in this case we're going up, so y approaches positive infinity as well. Our x-intercept happens where it crosses the x-axis, and so at that point our y value is 0, so it looks like it crosses our x-axis there at positive 3. Our y-intercept is where it happens, where x is 0, it's where it crosses the y-axis, so at negative 1. And then this is going uphill from left to right, so it is an increasing. You could also have a neither if it's a straight line, flat line. Okay, this time for the domain, it's all possible values of x. So really left, it's going left, so that's negative infinity. And then here, it's slowly going down and to the right, so positive infinity. Our range is our possible values of y. So it looks like it flattens out here. And our biggest number in this case happens to be, looks like negative 2. And then it's going down from there. So our biggest number, or our smallest number, excuse me, is negative infinity, and then it stops there at negative 2. And behavior, as x approaches negative infinity, y is starting to hug negative 2. So y approaches negative 2. And then as x approaches positive infinity, so the right-hand side, looks like y is going down really quickly to negative infinity. X-intercept, it doesn't cross the x-axis, so there is none. The y-intercept, it looks like it's crossing at negative 5. And this one is decreasing from left to right. And we always read decreasing from left to right. Okay, then we have some average rate of change. Here we are going to do over the function, so over our equation. So we're going to find f of r, negative 1, and f of 2. So 2 to the negative 1 is 0.5. 2 to the squared is 4. And then we're going to subtract that. 0.5 subtract 4 over negative 1 subtract 2. So that's what? Negative 3.5 over negative 3. Plug that into our calculator. And we get 1.16 repeated. And then if we're given a table, we're going to find f of negative 1 and f of 1. So negative 1, we have 8.5, and a positive 1, we have 10. We'll subtract 8.5, subtract 10, negative 1, subtract 1. So that's negative 1.5 divided by negative 2, which would be 0.75. Okay. And Mary's parents put $500 in savings account on her first birthday. If they save it in a bank with a 4% interest compounded yearly, how much money will she have in the bank by her 12th birthday? So 4% means we're going to multiply by 1.04 and her 12th birthday. Okay, so I'm going to make a table of values. So x and y. Okay. So on her first birthday, how much did they put in? 500. And then her second birthday, third, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12. Okay, so I got it a little squishy. Sorry. Okay, so we're going to multiply by 1.04 each time. And then we'll round to the nearest dollar. So let's see, 500 times 1.04. We get 520 times that by 1.04. And we get 541 times that by, and I just keep what's in my calculator and then hit enter between my values. And then I'm rounding to the nearest whole number. Technically, way